Hi everybody. I got many requests from the members of the groups to make some video tutorials. So if you open, I take screenshot of the discussions. One of the members was asking how we can bypass the verification of usernames or password or the login. And I answered that each app has different way, so each app should be treated differently. But he requested also like an example just to show how the logic behind it. So this is the first point we are going to address in this video. The second point, our friend here was requesting also a video tutorial because they are struggle working with Smali code and they don't know really what they do and where they start and how they start their investigation. As I mentioned many times, modding an app, it's like investigating a crime scene. So you need to collect evidence and you need to think how the developer was trying to protect their apps. And other things is just some skills you will slowly try to learn day by day if you are not afraid of try to understand a code. If you want just a fast solution of the modded version and look on compare modded, not modded, and don't analyze why this changes has been made, you are not going to learn fast. So my suggestion here is to try to crack an app, recommended a video app. So let's go to Empty Manager. This app is Mysplix Pro 3.5 revision 2. And as you can see here, I have the modded version. I already did that. And because this video tutorial is going to explain actually how Smali code works and some of the basics, I will probably go to this file here and show you some instruction, how we can understand it. Of course, I'm not going to go to all the instructions, but I'm going to explain those instructions maybe slowly, and I refer to this Smali bytecode to try to understand or look on search if this is the code exists in this file or not. Remember that what it is in the Smali bytecode file here is what is related to Java and Android, is not what the developer creating as a method for themselves. But the concept is exactly the same. So let's start first by installing the app. And before I install the app, I will show you that this app says that has no protection. So it's not like is encrypted or something like that. But in reality, there is some protection. I will show you this type of protection. But let's go and install it first. So this video, I will divide it in sections because for sure it's going to be very long. And probably some people cannot download like 200, 300 megabyte video to learn. So this is the starting of investigation. So when you want to investigate an app, you need to, when you open it, try to see what the app is asking you. First of all, app asking some permission, which is okay. Then we have this logo here, what we call the splash screen. Then the app detecting something in my phone. It said like, hey, you are not allowed to run this app because you have Lucky Patcher on your phone. So the app, when it starts looking if there is any, what they call that like illegal app on the phone, which is responsible of modifying their app or editing their app, and they will stop running the app. So there is some tests start at the beginning. So we are going first to try to attack this test. I will show you if I don't have any other button than exit. And wherever I'm going to click on the screen, nothing is going to happen except when I click exit. And when I click exit, the app is going to close. So I cannot go anywhere if I have this type of message. So if I click anywhere on the screen, nothing will happen except if I click exit. So the app closed completely, didn't allow me to go to the next step. So this is something interesting we need to look at, how we can bypass this type of message. So like I said, it's like crime scene. So we need to investigate, take evidence from what we are seeing here to try to see how we can find this information inside the code. So there is different way we can attack this problem. First way, we know that we have a dialog box, but we know that we have another dialog box under. So if you go to this dialog box and we try to look on the code, I don't know which dialog box I'm going to look at. Number 1, number 2, or probably potentially there will be more dialog box in the app. But this is something we can also look at. Like I'm looking for all the dialog box app here, and dialog box is actually Android. So you can find in Android what is the name of the dialog box in the code. This is one thing we can do. Second things, we know that this dialog box has a title, has a content, a text here, and has a button. So we are investigating this dialog box to see how we can find it in the code. So the title is has, if you look, has different font size than the remaining. So for me, this will give me an idea that the title is not written in the same time as the remaining of the code. But if I look on all the text here, if I look like on the word please, there is probably another dialog box has the word please in it. So it's not like a good word to look. I can write all the text here and try to find it. But what if the developer didn't use this text clearly as you can see it here, but it was an encrypted text? You will never be able to find it. So the third method how we can attack to this is when I click on the button exit, the app is going to close. And we know that in Android, the closing app, to close the app, what is the function? So we can go and look at this function also, see where inside the app, maybe there is another exit inside the app to exit the app. So will be 2, 3, 4, 5 places where the app has a button to exit. So we reduce the search to at least 4 or 5 places. Now, if we are lucky, my method first is to try to find a unique word inside this dialog box. Security detected probably is not unique. Probably any security detected, if someone has, other than Lucky Patcher, if someone has like APK Editor Pro, maybe the app will say, oh, you have APK Editor Pro, I cannot install it. Or you cannot run it. How the app knows that I have Lucky Patcher? This is also another way we need to think how the developer check that Lucky Patcher exists on my computer or on my phone. So Lucky Patcher or any other app has a very, very specific format of text saved on the phone. Like I don't know, app1.app. So it has a name. They will look at the name. If they found the name exists in your computer, in your phone, then the app will stop running. Say, hey, I got something. It will show me this pop-up and say, remove Lucky Patcher to make it work. But we need to make it work. So the first thing I'm going to check is a unique word. And a unique word for me is Lucky Patcher. Because usually Lucky Patcher is like 2 words. Lucky space Patcher. Here, they make it in a very specific format. They attach it all together. So this is maybe a sign for me that there is something, maybe I can play around. Let's check. So let's exit here and let's go to Empty Manager. We will go inside and we click on View to see the app. It opened all the file here. I explain in the introduction of Empty Manager that all the section is where the code is. Sometimes some of the code will be saved here. Like you see in the asset, I found the network code is here. So sometimes you need to go here and try to look to see what it is inside this file also. And the other interesting part will be this file, the resources, and the real resources file where all the XML exists here. In some games, library, lib, could be also interesting. But for us, we are not going to describe. We are going to focus on finding the Lucky Patcher things. So where I will start? I don't know. I open the app. I don't know where I will start. So in Empty Manager, and this doesn't require VIP or whatever. Everything I'm going to explain doesn't need VIP, guys. Do not spoiled by people who said you need VIP to be a really good modder. It's not true. First thing I will go and we do here, there is 2 types of search. The XML search and the other search. The other search, the first one, is the general search. So I start with this one. Here, I will leave it as all files, all extensions, anything I'm looking for here. Then I will click on Advanced Search to tell him what I'm looking for. So what is the word I'm looking for? I'm looking for a word. It's Lucky Patcher, but in one word. Let's say, okay, let's see if we are lucky to see something. This general search is going to search inside the DEX file and inside the XML file and inside everything. We didn't find anything. Let's see. Oh, you see why? Because of my problem here. Actually, I wasn't looking for Lucky Patcher, but I was looking for another word. Okay, let's look here. Let's do again. Oh, we have found 2. How many he will find? Okay, 2. Oh, interesting. If you notice, the word Lucky Patcher doesn't exist in any XML file, in anything. It exists inside the text file. So guys, when you see that, let me go back to the app. This box you are seeing here, when the app starts, dialog box, actually is completely created in the text file in Java. It's not created in XML file or whatever. So all these words here are all created inside the text file. We find 2 places. Let's go investigate these 2 places and see how we can bypass this. So I know that in 1 and 4, I will have it. So in the first one here, and the number 4. So I can go and said I want 1 and 4 to open. But my way is like, why I will do that? Let's open everything. And I know that between 1 and 4, I will find this message. But I will show you why I will select everything. Okay, so I go to search. And now I need to search the word Lucky Patcher. Yeah, is the correct. And I will search in all the paths. This is me when I make slash, so I'm an origin of my folders. And I need to search like without matching the case. If I want to match the case and I know that the exact word I'm looking for is capital L and maybe capital P, then I will do it like that and I will match the case. But for me, whatever, find anything related to Lucky Patcher just to guide me. And I will choose here Smali as the choice. It's mean look everywhere in any place in the Smali code. This guys could take some times. Here we have 5 files, text files, a lot of code inside this app. So if you don't know where to go, you will be lost for sure inside the app because the app is going to take you anywhere. There is like thousands of lines, if it's not million. But look, the search was very, very restricted actually. The word Lucky Patcher, how I look it with capital L and P, exists in one place. And the others are actually, you can see here, are actually the name of the package of Lucky Patcher. So these 2 places are very, very interesting. Let's go for the first one, see what it is. So we click here. I saw the Lucky Patcher was loaded as a string here. But remember, I don't have Lucky Patcher alone. I have it in a sentence, like I have all the remaining text. I cannot see it here. So they don't exist. So let's go very quickly and try to understand what this code do. Go down, app. Oh, I'm seeing something interesting here. First, I'm seeing parrot. So, piracy checker to check if I have anything to stall information. And if I go down, I have this package, but they are written in a funny way. Each letter apart, because when you try to look on the package, you are going to look on com, dot, whatever. Here they divide it in letter by letter to make it hard to find it in the search. You cannot find C alone because you will have million of C. Any C inside the code will appear, not just when it's alone. So this is a trick just to trick us to not find the message. But because I look on something very particular, I was able to find the Lucky Patcher here. And the package of Lucky Patcher is loaded here. Com, she, pa, 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 pa. So all this letter, you put them one close to each other, like here in this case, you put C, then O, then M, then point, then C, H, E, whatever. And you create the package name. Okay. So I go here, up, and I see the method. It's called getApps. Interesting. So this method, it seems that is going to check in on my phone on apps. Go inside. There is many apps he's going to check. It doesn't finish. Oh, so for me, like if I have the app also Game Hacker, I will receive this message. The Game Hacker. What else? Game Killer Sheets. I will receive also a message that you have games, all these apps. Okay, but what we can do here? Are we in the good place or not? We don't know. So wherever you are inside a method, like randomly, and you want to know the name of the method you are in, like now I am in method, I know that it is related to the app. You can click on, what's happened here? Okay. You can click on this surf icon, and it will tell you that you are inside the app Get Apps. The beta version of MT Manager, if you click here, you can find usage of this app. This is something very, very, very practical. Let's do it for now, and I will show you how we can do it in different way if you don't have the 2.9.1 beta version. And remember, this doesn't need you to be VIP to use these functions. So when you click Find Usage, before I click, I will show you something also interesting in this version. So this name here is Library Utility Kit, KT. Remember that. So I go here. Let's see where in the code somewhere the get apps has been called to check if I have any of this illegal app on my phone. It has been checked one time on the same library. So I will go to this place. It has been checked on this place here. So when this was called, this way here is mean like I'm calling the method get apps from library kit, who has this is as an input, the list, array list, and as an output is also an array list. So this get app has been called on this one place. So we are lucky. So when this lucky patcher appear on the screen when we open the phone, is because there is an other place calling this get app. And this other place is just one place, is here. So let's analyze this code here. And we see, okay, so this is very, very complex. First thing I look at, I click here again. And this method's called, look how funny it is, get pirate app. And this is all this input and the output behind. So let's go to this on the top of it. Oh, actually, you can go on top by click on it directly. It takes you on the top of the method. But the line we find is inside this method. So if we go on the top, this is the name of the method. The first thing, you have the name. You have parentheses. Inside the parentheses, you have all the input. And outside the parentheses, you have the output. So let's analyze this. The input of this has, first input is type of context. Second input, you see the Z here. There is no dot or any signal. This is 1, 2, 3, 4 Z, mean 4 logic input. So you have one context, 4 logic inputs, and an array list. So you have 6 input. One context, the first one, the other one are logic, and the last one as an array list. The output is interesting. The output is something came from my GitHub. It's called Pirate App. So the developer of this app use a package from GitHub to do it. By checking this is the same guy, this guy who write this package, is the same guy who write the HTTP canary, whatever. So it's, it's a very funny way to use someone else who did the job and add the package to your app. Okay, so let's see what we can do here. This get pirate, as I said, is going to take one input, other logic, and an extra app here as a signature, P5. So this is all the input. And when we go here, it's going to check the app. APK is going to check if the app was installed or not. Is going to call the package manager, which is something from Android. So when you install an app on your phone, you are going to use package manager. So this app will call package manager and check if this app is installed on your phone or not. After you do this, get package manager is going to check you all the app installed on your phone. And then from all this app is going to find the illegal app by comparing to the list he have it with the get app, like Lucky Patcher, Game Killer, or whatever. So this is a really funny way. And after, he keep doing again. He check other things inside. He check the stores. Okay, so all this is, to be honest with you, are still useless for me. I would like to know who also call this get pirate app. This get pirate app somewhere is calling get app. That where is the Lucky Patcher inside. But there is also another place in the code who called this pirate app method. So let's check out who called this method, because here I'm not going to go and check each method by itself and disable it. I need to disable it from the beginning to accept any app, not just Lucky Patcher. So let's do it again. Go here and find user. If we are lucky, we will not have very long list. Okay, we have one list. One place this app was called, it's in a piracy checker. The name is like scary. And this name is where was called in the GitHub. Okay, so let's go inside and see. Okay, so this is the method. It's called getPirateApp, was called on this line. Before this line, there was also loading all the extra apps, enable APK check, enable folder check, enable store check, enable app, unauthorized app check. So here, before they load this app here, he did all these checks before. And then there is a lot of if. So there is a lot of tests happen. If this is like that, do this. If this is like that, do that. So for me, I still think the return of this is, sorry, let's analyze the input and output. The input is a Z. So it's 0 or 1, true or false. This is as an input. Do you want to do extra verification or not? If you do extra verification, everything is going to happen inside this method because the return is just void. So do nothing. Everything is executing inside this. And let's say the message we see about Lucky Patcher is going to happen because all are going to be here. And when you finish, it's going to be void. Nothing is returned. Everything is happening inside. So the message is happening inside this box here. Now we got the lotto. We win. We find actually more precisely what's happened. We know from the name that it has one input, and this input is a Z, so it could be true or false, or 1 or 0. But this input is not set inside this, it came from somewhere else. So when this do extra verification was happening, before it happened, we will give this function or this method the input. We want to do the verification or we don't want to do verification. So here, if we go check where this do extra verification again was called, and we said, don't do the verification, put the number before this as a 0, so don't do this, it's not going to be executed any of this code here or any of the code inside it. So, again, I told you the way we go here, I can go here and do find user, but how we can do it in different way. So let's do it this time in another way. I know that this one, I copy it, and I know that this is exist in piracy checker. So I go back to my search, and I paste the function, and I search it, but I want to see this function came from piracy checker. So let's see who called this and how he set the 0 and 1. Okay, all this function was called inside the same application, so no confusion here, it's so easy to follow. One of it is the method where we was inside, and two other places are here and here. The method, we check it already. So if we go to the method, we check it already. The topper one is somewhere was called. So in this do extra verification, this was called, and the third places is here. So here, the third places was called inside verify function. In verify function, they said, okay, let's go, the one who want to learn Smali, this is a good function. The function name is do extra verification. It takes one input as Z and one output as void. So nothing is going to be returned. Everything is going to be executed inside this one. Now, if you see the remaining of the code is invoke direct, it has two parameters. It's a where the library do extra verification exists in piracy checker, who is exist in this all library in GitHub library. But this two input has two parameter here, v0 and p0. But look at this carefully. This is the secret. This function will take one input. So which input is this function going to take? v0 or p0? This function is going to take v0. P0 is what we called this dot, or it refers to itself, or it will be the output of this function. But here the output is a void, so there is nothing, so it's referred to itself. And this V0, the Z, is set here. And we know that if it's set to 1, true, it means do this extra verification. If it was set to 0, it's not going to do this extra, it's going to skip this. This is interesting. So one way, I can come here and make it 0. And we think that it works. And we test it and we check if it's going to work or not. But because we are not just beginner, we want to understand more what's happening here. We need to dig a little bit deeper again in the code and see. Before we do any changes, let's understand the code. Before this being called, there was a condition happen. So this message, or this lucky patcher message, is appear on my screen based on a test happening before. And this test, when this test has happened, he said in a condition, continue the next line or move to this line. We don't know what's happened, but we know that this is called condition 83. Let's go up and find where is this condition 83 happen. We go up, we go up, we go up, we go up, we go up. Oh, yeah, I see it here. Let's see if there is another place. So it's on line 1498, almost 1500. And if we go up, we are looking for 83 condition. We didn't find it. The only place make it jump directly is on this place here. So there was this condition. Is this condition, is it true? It will move directly to condition 84 and show this message. If it was false, it will move to the next step. What was happening before this condition? This condition said if V0 equal to 0. So if V0 got equal to 0, or in hexadecimal 0xO, move, jump to line where the condition 83 is. This was set at this function here, because the output of this function is AZ. So the output is 0 or 1. In this case, if it was 0, if enable LVL was false, then show this message. If enable LVL was true, then continue. Continue doesn't mean don't show the message yet. Continue mean don't show this message, don't execute the last message now. Something else we need to see. If the code when it flow naturally down, if it didn't jump, if it's going at the end to arrive here to do this, or is going to skip this step or not. So in this case, if you are on this line, it said skip to 87 to here, which is going to skip this nasty code. If he was here, naturally skip. So if the code are flowing naturally from up to down, at the end, without any condition, because here there is a condition, maybe it didn't jump, it continue. But if it arrive at the end, naturally is going to let you go and skip this nasty code. So, do we want how we can make this changes? As I said, I will try simply changing this to 0 and see maybe it will execute and said I have application but it doesn't show me the bad message, this bad boy message. I'm not going to see it. Or I will go up and modify all of this. Something else I like to check. Is all this test here inside this method verify? Is all this tests are related to this bad message on piracy checker? Let's see. The first one, function related to piracy checker. Piracy checker. Piracy checker error. Do not allowed. Something like, oh, piracy checker. So all this box seems for me still not the beautiful place. So maybe I can go deeper in the code and not let this verify function happen. Okay, let's do this. I like that. So let's go here and see who called this verify function. And remember, before we do this, you need to know what is the name of this function, which is piracy checker of this library. So we go here. Yeah, I didn't made any changes actually. I return it back to 1. Okay, this verify also happened twice. You see how many level we go up from the message, Lucky Patcher. We jump up now 5 times. We see who called this, who called that, who called this, who called that, and now we keep going up. And this way, this library, any app is going to use it. You can, for sure, mod it in the same way. Except if they did update for this package and they changed the code. So we have 2 places. Let's see the first place. This verify was also happening in all the policy, blah, 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 and in the start. So this is the beginning of this test. Oh, interesting. Let's see again, what does the second one say? Second one, you see it is annotation. So it's not inside the code. So more likely is going to be happen in any places here, but more likely in the init one. So this one here, that is a start. And this inside the start, we called verify. And inside the verify, we called another one, and another one, and another one, until we arrive to this message. So for me, it's the same concept. Let's see, in the start, what I like to see when I go to a method, I like to see those beautiful if jump. To see if there is any condition, well, to make it good or make it bad. Let's see, allow callback. If it was not equal to 0, the output, go to condition 12, which is here, and do this verify. If it was equal to 0, continue. Now you have another test. If this do not allow callback, not equal to 0, can again jump again to 12. Or continue here. But look, something interesting. Let's analyze it again, slowly. The first test, if allow callback was true, show this nasty verify test. If it was false, check now is do not allow callback, is it true? If it was true, again, show this nasty boy. If it was false, continue. But when you continue, blah, 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 you will finally arrive to the same place. So whatever I'm going to do in this method start, I will finish by executing this, whatever was the condition. So I'm not in right place. Who called the start? Let's do it again. I don't know, guys, if you have fun like me, but when I said you need to go deeper and deeper, deeper and deeper into the code, one changes can make all the difference. And this video got very long, but don't worry. It's very, very useful. So we have here 3 places. The last places is exactly the same. So we are not going to ignore this. Here we have 2 different places. One of them are very, very suspicious for me, the main activity. So once the app start is going to call this verify message method, where inside is going to verify if you have those app on your phone, blah, blah. If you have it, you appear this message. Suspicion. This is a good place to hack it, because I don't think we can go deeper than the main activity. The second place is the details activity. So let's see which one we need to start. For my experience, I will start with detail main activity here. And let's see. Remember, now this here is a bad boy. Okay? So this is what we need to remember, that this message is not something we like. And some of the colleague members, when I fixed this bad message, he got another message talking about the ad block. It's here. We can also disable this. So let's go see if there is any check to arrive to this, or just it flow naturally. Let's go up, let's go up, let's go up, let's go up. They're all flowing very, very naturally. There is no test. Okay. Go up, go up, go up, go up. Huh. Oh, very interesting. I will come back to this one. Let's go check the second one. Go back, go back. Do you notice that it looks exactly the same? Almost the same. What do you think, guys? In these 2 places, there is a lot of things happening before actually the real app starts. Let's go to the main activity and analyze the code. The onCreate code is when the app starts, and this will start, the onCreate. It said, first thing you will do, you will check some code here at the beginning, set them. Then there was a string. This string is encrypted string. You will decrypt it, and you will give the value of this decrypted value to v0. Then you will take this decrypted value, v0, and you put v1. I'll show it again. So this is a string. You take this string, which is saved inside the v0, you put it as the input of this function. You decrypt it. The decrypt version will be saved now here in v0 again. You put this decrypt version here. You put the v1 equals 0 here, and you will get the result saved in the this. You return it, and you save it in v0, and you continue. So here we have some encryption. Okay, guys? I will talk to this in the second video, how we can decrypt those nasty messages. But let's go again and see what's happened. So we have all this to say, okay, we have one string. Then here we have another string. Then it's going to check, is it dark? Is dark mode? When it's Z, it's asking, is it dark? Is it true? Continue. If it false, jump to 27. Now you see we have those stuff here. I will explain this part in the next video. The interesting things here, how the app is going to decide if it's dark theme or lighter theme, and how it load different theme, and then how we can bypass this nasty message. See you later.